Download this code from codegive.com, link in the description below. Max pooling and ReLU operations in TensorFlow. Max pooling and ReLU, rectified linear unit, are fundamental operations in deep learning, particularly in convolutional neural networks, CNNs. 1. Max pooling. Max pooling is a downsampling technique used to reduce the dimensionality of feature maps and retain the most important information. It works by sliding a window, or kernel, over the input feature map and taking the maximum value within the window. Key parameters *. Pool_size, the size of the window, example 2x2. Strides, the number of pixels the window moves after each operation. Padding, determines how the borders of the input are handled, valid or same. Advantages of max pooling *. Reduces the computational load. Helps to prevent overfitting. Retains the most prominent features. 2. ReLU activation function. ReLU is a simple activation function that replaces all negative values in the input tensor with 0 and keeps positive values unchanged. It is defined mathematically as \text ReLU, x, equals \max, 0, x, \. Advantages of ReLU *. Introduces nonlinearity to the model. Helps to mitigate the vanishing gradient problem. Computationally efficient. TensorFlow implementation. Let's implement both max pooling and ReLU operations using TensorFlow. Prerequisites. Make sure you have TensorFlow installed. You can install it via pip if you haven't done so. Code example. Below is a code example demonstrating both max pooling and ReLU operations in TensorFlow. Explanation of the code. 1. Input tensor. A 4D tensor is created with shape 1, 3, 3, 1, representing one image in a batch of size 3x3 with one channel. 2. ReLU activation. The tf.nn.ReLU function applies the ReLU activation to the input tensor. All negative values are replaced with 0. 3. Max pooling. The tf.nn.max_pool2d function performs max pooling on the output of the ReLU. It uses a kernel size of 2x2 and a stride of 2 to downsample the feature map. Output. When you run the code, you should see the following output. Conclusion. Max pooling and ReLU operations are essential components of many deep learning architectures. They help in reducing dimensionality and introducing nonlinearity, which are crucial for effective learning in neural networks. TensorFlow provides efficient functions to easily implement these operations, enabling the construction of powerful models. Certainly. Max pooling and ReLU, rectified linear unit, are two fundamental operations commonly used in convolutional neural networks, CNNs. Here's a detailed tutorial on both, including their purpose, usage, and examples in TensorFlow. Max pooling. What is max pooling? Max pooling is a downsampling operation commonly used in CNNs. Its primary purpose is to reduce the spatial dimensions, width and height, of the input feature maps while retaining the most important information. The operation works by sliding a window, filter, over the input feature map and taking the maximum value within the window for each position. Why use max pooling? 1. Dimensionality reduction, reduces the number of parameters and computations in the network, minimizing the risk of overfitting. 2. Translation invariance, helps the network recognize patterns regardless of their position in the input space. Max pooling in TensorFlow. You can perform max pooling using the tf.keras.layers.maxpooling2d layer. Example code. Explanation of code. We create a random input tensor of shape 1, 4, 4, 1, which simulates a single channel image. We define a max pooling 2D layer with a pool size of 2, 2 and strides of 2, 2, meaning the filter will move 2 pixels at a time and will take the maximum value in each 2, 2 region. Finally, we print the input and output tensors. ReLU activation. What is ReLU? ReLU stands for rectified linear unit. It is an activation function defined as \f x equals \max 0 x \. This means that it outputs the input directly if it is positive, otherwise, it outputs 0. Why use ReLU? 1. Nonlinearity introduces nonlinearity into the model, allowing it to learn complex patterns. 2. Efficient computation, it is computationally efficient compared to other activation functions like sigmoid or ten. 3. Mitigates vanishing gradient problem, helps in speeding up the convergence of the model during training. ReLU in TensorFlow. You can apply ReLU using tf.keras.layers.relu. Example code. Explanation of code. We create a random input tensor of shape 1, 4, 4, 1, with values centered around 0, which allows us to see the effect of ReLU. We define a ReLU layer and apply it to the input tensor. Finally, we print the input and output tensors. Summary. Max pooling is used to reduce the spatial dimensions of feature maps while retaining important information. ReLU is a popular activation function that introduces nonlinearity and helps in training deep networks efficiently. You can combine these operations in a CNN model for various tasks like image classification, object detection, etc. Here's a simple example of how you might use both in a sequential model. Combined example in a simple CNN. In this model, we use convolutional layers followed by ReLU activations and max pooling layers, demonstrating how these operations can be combined in a neural network for image processing tasks. You can run these examples in a local environment with TensorFlow installed to see the operations in action.